Okay, I'm not too satisfied with the visuals on that cone demo, so we're going to look at that again. When you're looking at it from the top apex angle, you can clearly see that the outer longer lines appear to be over 180 degrees as circled. And then we can unfold it and quickly get to the business we need to get to. And there's what we started out with. And some of these situations we'll be procuring near 180 degree angles and manipulating them over 180. Now going back here, what I was calling a 666 machine. We'll explain a little bit of that. On the 9-coil system, there are 6 areas of polar interaction that take place. The 6 areas of polar interaction reside on either side of the middle set of 3 coils. Now what we can do then is understand then that six places of magnetic interaction exist, and there's 6 possibilities of how we can make that magnetic interaction occur. By virtue of the use of tuned 3-phase mutual inductances, we can procure a situation either at 0 degrees, 60 degrees, 120 degrees, 180 degrees, 240 degrees, or 300 degrees. Those are the 6 options and the 6 places where those options can exist. And we're looking back at the calculator. I'd like to get done with this. Well, then what we understand is that when we go through all the options, we see that when we get halfway through the options, that no longer as many options exist, because the middle set of coils being used to generate those options has a predetermined option halfway through the sequence. So then we divide by 9, just like we did with the magic square, and we find out that there's at least 5,184 manipulable states. Now then, having covered all that, we'll turn the machine on. And the machine, actually, what we're concerned with, we'll go ahead and turn the machine on, get through this. We call the complete demonstration ringing the bell, but I don't think we'll get that far in this video. Right now, we have only phase 2 employed. Phase 2 is consuming 0.071 amps. We have the vicinity of phase 1 and 2 next to it, which have not yet been connected to their lines. Prior to their line connection, we wish to demonstrate what forces of EMF exist in space itself to influence that. I'm losing my memory here. Okay, well, anyways, then what we're going to do is note that make sure all of our stator voltages are working. We've got 1.1 there. 1.3 and 1.2. Don't seem like we're getting any delivery line amperage on one of them. That's uncharacteristic. Typical, always problems. We'll see about that as things continue. Okay, what we're going to do then is hook up phase 1 as an air core secondary. We're starting out with 0.07 amp. What happened there? Oh goodness. Well, we want to be down here. Okay, we added phase 1 as a secondary, and we retrieved 0.48, and our impulse amperage from phase 2 as the primary went up a little. Now we'll engage phase 3. We've engaged phase 3 and we see that we're getting 0.065 on the right, we're getting 0.05 on the left. That's 117, 0.117 amp coming out, 0.0708 amp from phase 2 going in. So in the analogy of tuning forks, it don't seem like phase 2 has changed much. Well, now what we're going to do then is consider them as pre-existent magnetic forces, and they're going to contribute to the vector addition of the actual amperages that we see on all 3 meters, how it changes everything once we actually hook things to the line. Phase 1 to the line. Phase 2 to the line. There's our completed system. Noted that then the ratios changed, but that's what we're getting out. More importantly, this is what we're interested over here. Our ratios of voltages. And then we can see that we got 9.4 volts on 1 VI, 17.2 volts on 3 VI, which would sum to 26.2, but yet the voltage that we're reading, it would sum to 26.2 if in fact the voltages were 180 degrees out of phase, but in fact we're reading roughly probably 4% over that value at 27.4. So we see that a sort of time distortion effect has been taking place by the coil, and we'll have to stop for that video.